Hey, folks, thanks for, sticking it out and dealing with the pain of trying to learn something pretty abstract and complicated. This isn't easy. This isn't kind of beginner type math. So I want to, give you some kudos for sticking it out. It's going to take some time for your brain to kind of adjust to this abstract idea, right? That's normal. You're not dumb. That's just what normal human beings have to do. So what we're doing is, we're trying to find unknown sides in this triangle. We only have an angle and one side. If we had two sides in this right triangle, we could use Pythagorean theorem, right? Which maybe isn't that abstract to us. It's more familiar and all that kind of stuff. And when you set up these ratios like we did yesterday, we're using tangent on this problem because we have the opposite leg and we wanted the adjacent leg, right? And that puts the variable, if we use the 32-degree angle, that puts the variable in the denominator because the opposite leg from 32 is 11 and the adjacent leg is x. So I said on this particular problem, you could find the other acute angle. We need to do that anyways. When it says solve, it means find all the unknown pieces, right? So this angle right down here is 58 because 90 minus 32 gives us 58 degrees. Okay. Why am I saying 90? Why am I not saying 180? Well, there's already 90 used up for this angle, right? So these two acute angles have to add up to be 90 or they're complementary, right? So we got 58 degrees. Now, if we use the 58 degree angle, x is the opposite leg from the 58 and 11 is the adjacent leg. So that puts x up in the numerator, which is fantastic, which makes it easier to solve because all I need to do is multiply both sides by 11. And that's what I'm doing right here. I'm multiplying this side by 11 and this side by 11, right? Now, let's think about this for a second. Y is the hypotenuse. And when we look at our mnemonic device here, so ka, toa, the H part, which stands for the hypotenuse, is always the second letter, which means that it's the opposite leg over the hypotenuse. It's the adjacent leg over the hypotenuse. The hypotenuse is in the denominator every time for sine and cosine. So when I set up the cosine of 58, I go 11 over y. Or if I set up the, let's say I did the sine of 32. Okay, let me do the sine of 32. That would be 11 over y, right? There's no way to put y up in the numerator. So we have to know how to solve these types of equations when y is in the denominator. And the way that we're going to solve them is we're going to multiply both sides by y, by the variable, okay? So let me move this up the screen a little bit. And you might say, well, why am I going to do that? Well, it's really cross multiply isn't like a special operation. What we're doing is we're multiplying both sides by the denominators. So when I multiply 1 times 11, right, that's really what's happening here. I'm multiplying this side by 1, this side by 1. You don't really need to multiply by 1. But we definitely need to multiply both sides by y to get the y out of the denominator, right? So if I multiply this side by y, I'm going to multiply this side by y. And the y's divide out to 1. And now we've got y times the sine of 32. And here's the rub is sine of 32 doesn't look like a number. It's a number on our calculator or on our computer, right? It's on Desmos. So we're going to divide by the sine of 32 on both sides. And when we do that, the sine of 32 divides out to 1, right? So look how the sine of 32 ends up in the denominator of my expression, right? Now we just have to jam over to Desmos and get over to Desmos here. And we always have to remember every time we open up a new Desmos, it thinks I want to be in radian mode. Now, maybe there's a way to force it to remember, hey, this is the mode I want to be in. But I think we had something like 11 divided by, what was it, the sine of 32, I think. So let's look over there again. Yeah, 11 divided by sine of 32 comes out to be 20.76, let's call it, if we need to round to the hundreds place. So what you do next is you put down 20.76 and you put a little dot over the equal sign saying it's an approximation. Or you can make a double equal, double squiggle, whatever you want to call them, approximation symbol. All right. Sometimes you have to deal with that variable in the denominator. There's no way around it. This is what I'm talking about by abstraction and by complicated problems. These aren't super easy problems to understand. It's going to take your brain some time to process that, right? So let's look at this one, number 23. We only have one side. Like I was saying, we have one side and an angle. And I would like, this side, and I'd like this side over here. Now, to get the other angle, that's pretty easy. I hope that we can say, okay, that's 33 degrees because 33 and 57 make 90, right? So let's put an X on this side. I know that they used an X up here, but I like the variable X. And so I'm going to say, let's see, there's the opposite leg. Here's the hypotenuse. I'm going to say the sine of 57 is equal to X over 18. Okay. I could do the cosine of 57. That would equal Y over 18 because the adjacent leg over the hypotenuse. And these are a little bit easier to solve, right? Because I just need to multiply both sides by 18. It's when the variable is on the hypotenuse that you have no choice. The variable is going to be in the denominator, and you've got to mess with this kind of algebra, like an extra step of algebra, right? These, I hope, are starting to look a little bit easier, like just multiply this side by 18, multiply this side by 18, and the 18's on this side, divide out, and we've got X all by itself, 1X, not 1X divided by 18. I have X now, and so I go 18 times sine 57, right? Or 18 times cosine of 57, and you're done with problem number 23. Hey, thanks for watching my video on kind of a review of the basic SOHCAHTOA. I'm going to do the rest of these problems here on 2 more videos, but you definitely want to have this in your notes. You definitely want to know how to use that. Again, I appreciate your effort.